Vertical rectangular gate, 1.2 meters wide and 1.8 meters high. Hinge at the top has water on one side. What force applied at the bottom of the gate at an angle of 45 degrees with a vertical is required to open the gate when the water surface is at the top of the gate, 0.9 meter above the top of the gate, 0.9 meter below the top of the gate. So for the first situation, that's the figure. This is the location of the force since the water surface is at the top of the gate. That's the hinge. Then the pressure diagram is triangular. So barred H, 8 sub CP rather is 2/3 of 1.8, so 1.2. So there's no need to locate that by experience. So summation moment about the hinge equals 0. The only component of P that has moment about P is the horizontal component, and that is P sine 45 times 1.8 equals F times 1.2. That's for the first situation. P sine 45 times 1.8 equals F times 1.2. Where F is specific weight of water, barred H is half of 1.8, so 0.9, area 1.2 times 1.8. So F 9.81, 0.9, 1.2 times 1.8. So F is 19.07 kilonewton. Substitute in the equation. P sine 45 degrees times 1.8 equals 19.07 times 1.2. So P is equal to 17.98 kilonewtons. For the second part, the water surface is 0.9 meter above the top. So this is now the situation. This is the location of the force through the center of pressure, but this time we solve for the distance from centroid of area to center of pressure, EVR. Barred H this time is 0.9 plus another 0.9, so 1.8 barred H. So the equation, summation moment about the hinge is P sine 45 times 1.8 equals F times 0.9 plus EVR, is a VR. So that's the working equation. P sine 45 times 1.8, summation moment about the hinge, equals F times 0.9, half of 1.8, plus E sub VR. Where F is 9.81, barred H. Barred H is 0.9 plus 0.9 or 1.8. Area is 1.2 times 1.8. 9.81, 1.8, quantity 1.2 times 1.8. So F is 38.14 kilonewtons. Then AVR formula, height of rectangle square over 12 barred H, where barred H is 1.8. So this is the formula I use also in the many problems before this problem here, or you can derive this if you want. So 0.15 meters, substitute P sine 45 degrees times 1.8 equals 38.14 times quantity 0.9 plus 0.15. So P is 31.46 kilonewtons. Then for the last situation, the water surface is 0.9 meter below the top of the gate. So this is now the situation. The pressure diagram is still triangular. So we can locate F easily, 2/3 of 0.9. This is now 0.9. 1.8 minus 0.9, so 0.9. So 0.6 from the water surface, or 1/3 of 0.9, 0.3 from the bottom. So if this is 0.3, the line of action of the force F is 1.5 meters from the hinge. So the equation, summation moment about the hinge equals 0. P sine 45 times 1.8 equals F times 1.5. So take note that F is in contact with the lower half of the area, where barred H is 0.45 And 0.45 is half of 0.9. This is 0.9. So F is 9.81 times 0.45. Area is 1.2 times 0.9. So the depth is 0.9 also. The area that is in contact with the gate is only 1.2 times 0.9. And half of 0.9 is 0.45. That's barred H. So F is 4.768 kilonewtons. Substitute in the above equation. P sine 45 degrees times 1.8 equals 4.768 times 1.5. Solving for P is 5.619 kilonewtons.